Number 64. Calculate the contact angle theta for olive oil if capillary action raises it to a height of 7.07 centimeters in a glass tube with a radius of 0.1 millimeters. Is this value consistent with that of most organic liquids? All right, so basically we're talking about contact angle, and we know there's a formula we know that has contact angle in it. It says the height at which a fluid rises due to capillary action will be equal to 2 multiplied by the surface tension of the object multiplied by cosine of what's called the contact angle, divided then by the density of the fluid times gravity times then the radius. So we're asked to find theta, right? So what do we got to do? We got to solve for theta. All right, so let's start rearranging these items. So basically all we have to do here, take all of these units, just bring them across that equal sign like a cross multiplication, okay? And then bring this to gamma down on a cross, create your little division sign here, and voila. I mean, here's the equation. So simple, all right? So here we go. And you can do that anytime you got two fractions, right? Anytime you have A over B equals C over D, or anytime you can make this, all you got to do, you're allowed to move the terms across the equal sign. I don't care how you do it, but you're allowed to do that, just not diagonally across. You're not allowed to move it, horizontally across. And you're also not allowed to move it vertically, just diagonally. All right, enough of that. Let's get that out of the way. So all we got to do now is, again, so this isn't really the overall formula, but this is cosine of theta, what that equals. Now we're going to take the inverse cosine of both sides, right, in order to find just the angle. So basically the angle now will become inverse cosine or cosine to the -1 of density times gravity times R times H all over 2 times the surface tension. All right, and we have all these values. Just make sure you put them in the standard units. So we have the inverse cosine -1 of the density of olive oil. That had to be looked up. That's 920 kilogram per cubic meter. So that's 920. Gravity, hopefully you don't have to look that up. That's 9.8. The radius, they told us the radius was 0.1 millimeter, which means it's going to be 0.1 times 10 to the -3 meter. And then in terms of the height, they told us the centimeter. So it's 0.707 times 10 now to the -2 meter. Okay. And then all divided now by 2 times the surface tension. And the surface tension is going to be 0.032 Newton per meter. 0.0332. Come on. There you go. All right, now everything is in the standard units now. All you have to do is just plug it on into the calculator. Let's see what we get. So inverse cosine of 920 times 9.8 times 0.1 times 10 to the -3 times 7.07 times 10 to the -2. Divided now by, in parentheses, 2 times 0.032. Close those parentheses, and what do we get? We get a value of about 5.14 or so, 5.14. And that's in terms of degrees. All right, and then it says, is this consistent with most organic liquids? I mean, if you look that up on your table now, most organic liquids have a theta value of about 0. So I mean, this really isn't that far off from 0. So it's fairly consistent. I don't know, is it consistent? What does that term mean? What amount of uncertainty do they want us to give? Right? It just says is it consistent. So that's a little ambiguous, and that could be left up to interpretation. So it's fairly consistent. It's not exact, but it's fairly consistent. Guys, thanks for tuning in. Appreciate it very much. Please remember to subscribe. See you next time.